Welcome to AxisVM. In this video tutorial, we will cover the design of the membrane model described in the AxisVM step-by-step tutorial. We will cover the design of the model using domains as well as an analysis, and the slab will be designed according to the Eurocode 2 standard. In AxisVM, create a new model. In the dialog window, set the model file name to membrane2. Select Eurocode from the design codes and set the units and formats to EU. Click OK to close the window. Then change the view mode to the XZ plane. Select the Elements tab and click on the Draw Objects Directly icon. In the window, click on the Domain icon and click on OK to browse the material library. Select the C25/30 concrete material from the list and then close the window. Then, in the window, change the type to Membrane Plane Stress and click on the complex slab icon to define the coordinates of the domain. Determine the starting point of the polygon by typing x0, y0, z0, then enter. The next coordinates will be entered relatively to previously entered points. Enter the next 8 coordinates as shown in the video or in the written tutorial, and press enter when finished to finish the object drawing. After entering all the points, click on the Translate icon. Select the top horizontal line and finish the selection with OK. Choose Incremental from the Method panel, set n equals 1, then close the window. Specify the translation vector by typing x0, y0, z minus 0.8. After hitting enter, the blue line on the inner contour of the domain will indicate the type of domain. You can move the cursor over the line to display the domain properties. Now click on the Mesh tab for the domain meshing. Click on the domain meshing icon and select all of the elements. In the next window, after clicking OK, type in 0.7 for the average element size. Clicking OK will start the meshing. When the mesh is completed, you can move the cursor over a surface center to display information about the element. Now return to the Elements tab. Click on the Line Supports icon and select the bottom lines of the legs of the model. Click OK, and in the window that appears, set all of the values to 0 except for the Rx and Rz values. After closing that window, the finite element definition of the wall has been completed. We will now proceed with the analysis of the model. On the Loads tab, click on the Surface Edge Load icon and select the second line we created earlier. Click OK. In the next window, set Py to 50 kilonewtons per meter. Click OK to apply the load. After applying the load to the wall, we will conduct the analysis. Click on the Static tab and then on the linear static analysis icon. The program will check the model and suggest a setting for the degrees of freedom. Accept with yes and the analysis will run. When the analysis is complete, the program will automatically display the vertical deformations in the Z direction in the Isosurfaces 2D view mode. In the display options, uncheck the Loads checkboxes for a slightly better view. From the drop-down menu, change the display to the Surface Internal Forces NX component. The NX diagram shows the membrane forces in the local X direction. To find the locations of minimum and maximum values, use the min-max values function. Select one of the surface components and confirm with OK. This shows the maximum negative value and its location. Clicking OK will show the maximum positive value and its location. The color legend shows the boundary values of each color. Change the color boundary values by right-clicking on the legend and selecting Other Settings. Change the default minimum negative value to -100 to clearly show the surface forces. Press Enter to finish and switch on Auto Interpolate. Then press OK. Areas with an NX surface force exceeding -100 kilonewtons per meter are hatched in blue. Then let us take a look at the internal forces in the ISO-lines display mode. From the drop-down menu, select ISO-lines, and then change to the RZ component in the other drop-down menu in order to view the internal forces of the supports. Click on the Result Display Parameters icon and check the Write Values to Lines checkbox. This will show the internal force values on each support. The next step is to calculate the required reinforcement of the wall. Click on the RC Design tab. Click on the Reinforcement Parameters icon and then select all of the elements. After clicking OK, set the Materials tab. Set the structural class to S3. Then set both exposition classes to XC2. Click OK to close the dialog window. The AXB diagram will be displayed in the Isosurfaces 2D view, and the required specific reinforcement in the X direction will be the sum of the AXT and AXB values. Thank you for watching this tutorial video. More details, including an alternate definition of the model geometry, can be found on the AxisVM website.